Hello, everybody. So this is the video for the 6.1 notes. We're going to talk about proving and applying theorems about lines and angles. Most of what we're going to learn about today is about parallel lines. This is our first lesson in the world of geometry. So maybe some of this will be a review, maybe some of it won't. Either way, that's okay. As long as everybody has the notes and are ready to go, I'll go ahead and get started. So our first vocabulary word today is what's called the transversal. This is a line that intersects two or more lines at different points. So in the picture to the right, line P would be an example of a transversal because it intersects lines Q and R. Our second definition is supplementary angles. These are angles that add to 180 degrees. These are also known as linear angles, linear pairs, or straight angles. These are two angles that are next to each other on a line. So for example, on this image, if we look at line Q here, angle 1 and angle 2 would be an example of supplementary angles, since those two angles added together has to be 180 degrees. The next definition is complementary angles. This is angles that add to 90 degrees. We have no examples of this on the image shown, but if we were given something like this and we knew that it was 90 degrees and we had some other line that cut that angle, we would know that those two angles, maybe we'll call this angle 1 and angle 2, those two angles would be considered complementary. Okay, definition number 4, this is vertical or opposite angles. These are for the definition here is two adjacent angles formed by two intersecting, let's make that a little bit thicker. Intersecting lines. Vertical angles are congruent. Congruent is the geometry word for equal. They are equal in length. And the symbol that we use for congruent is that symbol. So if we look at this image here, we can see that angle BEC and angle AED, those two would be considered vertical angles, this angle right here and this angle right here. And we know, based on the definition, that angle BEC is congruent to angle AED. Okay, our next definition is corresponding angles. So these are angles formed when two parallel lines are intersected by a transversal and are in the same position. At each intersection. Corresponding angles are congruent. Okay, so let's dissect that a little bit. Angles formed when two parallel lines are intersected by a transversal, and are in the same position at each intersection. So again, looking at this image, corresponding angles, we've got two lines that are intersecting, we've got a transversal, and then they're in the same position. So what we mean by that is like angle 1 here is in the same position as angle 5. So an example would be angle 1 and angle 5. Another example could be like angle 3 and angle 7. Those are in the same position and would be considered corresponding angles. Okay, next definition. Same side exterior angles. So this is angles outside of the parallel lines and on the same side of the transversal. Same side exterior angles are supplementary. And again, we defined that earlier, that means they add to 180 degrees. Okay, so angles outside is associated to that word exterior. And the exterior is like these sections out here, outside the exterior. And then they're on the same side of the transversal. So that would be like angle 1 and angle 8. Those are exterior angles that are on the same side here, the left side of the transversal. So angle 1 and angle 8 are examples of same side exterior angles, and if you added those together, they would be equal to 180 degrees. Okay, definition number 7. This is for same side interior angles. This is angles on the same side of the transversal and inside of the parallel lines. Okay, so again, same side interior, that word interior means between the parallel lines, so this would be considered the interior. And we're talking again about the same side, so angle 4 and angle 5 are on the interior on the left side of the transversal. So angle 4 and angle 5 would be considered same side interior angles. Okay, and our final definition for this page is alternate side exterior angles. So these are angles outside of the parallel lines and on the opposite side of the transversal, they are congruent. So again, let's refer to this image up here. So now we're again talking about the exterior angles, but we instead of the same side, we're talking about alternate side, so meaning opposite sides of the transversal. So if we're on the exterior and on opposite sides, an example of that would be like angle 7 and angle 1. They're on the exterior of the parallel lines and on opposite sides of the transversal. So angle 1 and angle 7 would be an example, and we know that those two angles have to be congruent. Okay, our next page Our first definition here is alternate side interior angles. So this is going to be angles on the opposite side of the transversal, but inside the parallel lines. They are congruent. Okay, so on our image, again, we're talking about the interior and alternate sides as two different sides of the transversal. So let's pick angle 4 here, since that's on the interior. The opposite side interior angle would be angle 6. So angle 4 and angle 6 would be an example of alternate side interior angles, and we know that they are congruent. Okay, definition number 10. This is a perpendicular bisector. Perpendicular bisector is a segment, line, or ray perpendicular. And the symbol that we use for that is like an upside down T. To a given segment that cuts the segment into two congruent. Again, the symbol is this, two congruent parts. So for this image here, we would say that line CD is the perpendicular bisector of line AB. And because of that, it's going to cut AB in half. So line AB, line AE would be congruent to line EB. Okay, so let's look at an example of how we could use this information to figure stuff out about angles. So this question asks us to identify the pairs of angles that are vertical angles, corresponding angles, and alternate interior angles. So vertical angles, we know that those are opposite of each other. So that would be angle 1 and angle 3, angle 2 and angle 4, angle 5 and angle 7, angle 6 and angle 8. And by definition, those angles are congruent. Okay, corresponding angles. So to remind you, corresponding angles are the ones that are in the same position on the image. So that would be angle 1 and angle 5. Angle 2 and angle 6. Angle 3 and angle 7. And then angle 4 and angle 8. And by definition, corresponding angles are also congruent. And then the alternate interior angles, again, we're talking about the interior, so this would be like angle 4 and angle 6, as well as angle 3 and angle 5. And again, by definition, alternate interior angles are congruent. Okay, and question number 2, I'm going to shrink this a little bit so we can still see the image, says, Given the measure of angle 1 is equal to 72 degrees, find the measure of the remaining angles. So you can do this in whatever order you want, but if we just do them in the order they're given, we know the measure of angle 1 here is 72 degrees. And we want to know the measure of angle 2. Well, we know that those two angles are supplementary, meaning they add to 180 degrees. So the measure of angle 2 must be 180 minus 72, which is 108. Okay, then if we continue, the measure of angle 3, well, that is a vertical angle to angle 1, so it must be 72 degrees. The measure of angle 4 is a vertical angle to angle 2, so it must be 108 degrees. The measure of angle 5, well, angle 1 and angle 5 are corresponding angles, so it must be 72 degrees. Angle 6 is a corresponding angle to angle 2, so it must be 108 degrees, or you can think of it as supplementary to angle 5. Angle 7 is a vertical angle to angle 5, so it's 72 degrees. And then angle 8 is vertical to angle 6, so it's 108 degrees. Okay, so now I want to show you a couple examples from your homework of how we can use these types of definitions and theorems to solve geometry problems. So if you need to pause the video to hand out the homework, please just go ahead and pause the video and make sure that everybody has the homework. Okay, so here's the homework. Let's just look at this first question together. So we're asked to find the measure of angle B. So if we look at this image below here on number 1, we're trying to figure out how B relates to the angle that we've been given. Well, if we were to look back at our notes, we know that vertical angles are opposite angles on two intersecting lines. And if we kind of ignore this line right here, we've got two intersecting lines, and those are in fact opposite angles. So we can conclude that B is equal to 30 degrees. And I think it's helpful to write down what definition you use to figure that out. You don't have to, but I think it's very useful. So those are vertical angles. So B is equal to 30. Question number 2 here. Again, we're trying to figure out the measure of angle B, and we can see that it is complementary to the 48-degree angle that we've been given. So we know these are complementary angles. And so because of that, we know that 90 minus 48 will be equal to B, which if you do that, we find that B is equal to 42 degrees. Okay, I'm hoping these are making sense. Question number 3. Okay, so let's dissect this one a little bit. We can see that we have two parallel lines here. That's what these little arrows mean, is that these lines are parallel. And then this line represents a transversal. So because of that, we can look at these two angles as being, and like compare their relationship. They're on the exterior of the parallel lines. They're on the opposite side of the transversal. So these would be alternate exterior angles. And alternate exterior angles are congruent, so we know that B must be equal to 128 degrees. Okay, let's do one more of these together. So question 4, again, let's dissect it. We can see here that these two lines are parallel. This line crossing across them would represent a transversal. So we know we can look at the relationship between B and 80 degrees. They are on the interior of our parallel lines on opposite sides of the transversal. So these would be alternate interior angles. Alternate interior angles are congruent, so we can conclude that B is equal to 80 degrees. Okay, I hope that those made sense. I'm going to have you do questions 5 through 8 on your own. Okay, let's look at a couple more examples. These ones are a little bit more complicated, but the same principles apply. So we're given an image, and we're going to use our definitions from today to figure out the value of x. So let's do a couple of these together as well. Question number 9 here. We see these two angles. My first inclination is that maybe they're vertical angles. And again, vertical angles result from two lines intersecting. So if in my mind, if I imagine that one's not there, I can see we have two lines that are intersecting, and they are opposite of each other. So because they're opposite, I know they're congruent, which means they're equal. So this would be 6x plus 4 equals 88. So again, I think it's helpful to get used to describing the definition that you're using. And then here, now that we have an equivalent statement, we can just solve for x. So we would subtract 4 from each side, and we end up with 6x equals 84. Divide by 6. And we find that x is equal to 14. Okay, great, let's do another one. So number 10, we can see that they've shown us that this is a 90-degree angle. So my first inclination is that these are going to be complementary angles, which in fact they are. So because of that, I know that 54 plus my 3x plus 6 angle has to add up to 90 degrees. And then once I have an equation, all I need to do is solve it. So 54 plus 6 is 60, plus 3x equals 90. Subtract 60 from each side, and you get 3x equals 30. Divide by 3, and we can conclude that x equals 10. All right, question 11. Okay, I'm looking at this. I don't see parallel lines, but maybe they're vertical. And if there's one of these that I can kind of ignore and see that they really are opposites, I'll be confident they're vertical. And it looks like I can. So these are in fact vertical angles, which means that 74 must equal 4x plus 2. Solve for x by subtracting 2, we get 72 equals 4x. Divide by 4 on both sides, and we can conclude that x is equal to 18. Okay, let's go ahead and look at one more. So number 12 here, let's dissect this again. So it looks like we've been given some parallel lines and a couple of transversals here. We have two transversals, but this one's closer to our angles. If we look at where those are positioned, they're in the same position on the image, so these must be corresponding angles. And corresponding angles are congruent. So we know that 3x plus 1 equals 127. Go ahead and solve for x. We get 3x equals 126. Divide by 3 on both sides, and we can conclude that x is equal to 42. Okay, so I hope that those examples made sense. The other problems from your homework that are relevant to what we've done so far are questions 13 through 20. Those are the ones that you're going to need to use the definitions to answer the questions.